Hi everyone, welcome to GemChem. Now today's topic of discussion is polyalkenes. Now before starting, you can watch the videos on alkenes. I will give the link in the description box as well as the I button present above this video. And if you are new to GemChem, do not forget to subscribe the channel. So let us start. So what are polyalkenes? Those molecules which have many double bonds within them, those molecules are known as polyalkenes. These double bonds are mainly 2 or more than 2 in number. So we have three types of polyalkenes. One's those which have isolated double bonds. Suppose you consider a simple molecule, for example, and in that case if you see the bonds which are present is far away from each other, then they are known as isolated double bonds. So this is a molecule, for example, CH2C double bond CH. Then we have two more carbons followed by another CH double bond CH. 2. So here you can see 1, 2, 3, 4, 5, 6. So once we have one double bond in 1, 2 position and another double bond 5, 6 position. Now if we talk about the next one, that is the next type, it is hydrocarbons with cumulated double bonds. So in this case, if you see, cumulated means one after the another. So we have double bonds in continuation. So somewhat like this the structure will be looking. The double bonds will remain in continuation. For each of these types we will go into details, but first an introduction is being given. Now in the last type is hydrocarbons with conjugated double bonds. So you will have the double bonds alternate to each other so that they can undergo resonance. And this resonance concept is also being explained in the channel. You can watch it. I will give the link in the description box as well as the I button present above this video. So this can continue. Now today we are going to discuss about the first two types, that is hydrocarbons with isolated double bonds and hydrocarbons with cumulated double bonds. We will see few properties and reactions and the method of preparation. So if we shift for the next one, that is first hydrocarbons with isolated double bonds. So here we see an arrangement where there is a carbon present and we have a double bond CH. Then we can have a hydrocarbon chain with n number of carbons in it, followed by again CH double bond C, where we consider this n is greater than 0. So one of the simplest compound which we can see is hexa 1,5-diene. So you can try to draw this one, hexa 1,5-diene. So in this case you will see that here we have CH 2 double bond CH. So this is 1, 2, then we have in 5th carbon the another one double bond. So we are left with two more carbons which are CH2 and CH2. So this is the simplest unit that we can consider. Now if we proceed to the method of preparation, this can be easily prepared using Wood's reaction with allyl chloride. When you try to make symmetrical alkenes, you can use 2 alkyl chlorides and use sodium along with ether to join them together to form a symmetrical even alkane. Here we are using it to make polyalkenes. Now see, if we start to write the synthesis method, so how can it be done? If you consider or take allyl chloride, that is this one, CH2 double bond CH, CH2 Cl, and you add magnesium to it, then what happens is in presence of ether, it is observed that 2 units of this one fuse together and chlorine goes away. So we have CH2 double bond CH, CH2, another unit joins together CH2, CH double bond CH2, and the byproduct is MgCl2. The magnesium comes from here and the 2Cl comes from this side. This is the method for preparation of hydrocarbons with isolated double bonds. Now we will see detailed discussion on hydrocarbons with cumulated double bonds. Now if you see in any of the molecules, the arrangement is like this. That is, you have C, double bond C, double bond C in continuation. It is known as hydrocarbons with cumulated double bond. Now in this case, it is very essential that which is the simplest compound. Now just put hydrogen in it. So the molecule which is being generated is known as alene, or you can say it as propadiene. If you are confident about nomenclature, it's fine, but if you find it quite difficult, you can refer to the videos of IUPAC nomenclature already present in GemChem videos. So I will give the link in the description box as well as the I button present above this video. Now once we see this common and most simplest compound, then we need to know its preparation. So first method of preparation of alene or these types of double bonds, let's start doing. First we need to take 2,3-dibromopropene. So if we want to get 2,3-dibromopropene, we need to start from an initial stage, that is 1,2,3-tribromopropane. So what is 1,2,3-tribromopropane? CH2, 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 and each of these have a bromine. Now if you add alcoholic KOH, what will happen? HBr gets removed. So if I first remove HBr from this side, then we get our desired starting material for preparation of alene, that is CH2, double bond C, Br, CH2, Br, and this is actually 2,3-dibromopropene. If we now add zinc dust in methanol solution, then we get alene. What happens is that bromine gets out. So what is the reagent? Zinc in methanol, and we obtained our desired product alene. So this is the structure, right? Now this alene is a gas and its boiling point is -32 degrees Celsius. With bromine, it will form different compound, not this one. When you add bromine to it, let's see what happens. Take the alene first in your copy. This is your alene, right? So you have to add bromine to it. Once you add bromine to it, Br2, it will form 1,2,2,3-tetrabromopropane, and this reaction we can easily do. See here, CH2 we can put one Br here, all the double bonds gets opened up. CH2, Br, here we have Br, and here also Br, right? Now if we continue with this moieties reaction, if we add to it sulfuric acid, H2SO4, what happens is that we can get acetone from it. So first step, we see that there is a addition of H and OH. So here we have OH and here we have CH3. Next step, if we further proceed, what happens is this OH bond gets broken and this opens up. This hydrogen is shifted to this carbon. As a result, we get acetone, CH3, C double bond O, CH3. Now if we see another reaction of alene, here we have CH2 double bond C double bond CH2. So we add to it sodium ether, which is a good electron source, as a result of which we will get an alkyne. So from cumulated double bond, we are obtaining a alkyne, right? Now in the next case, if we try to get from alkyne a cumulated alkene, what is the method? Let's see. So if you consider this one, this alkyne CH triple bond C, CH2 CO2H in aqueous K2 CO3 heated at 40 degrees Celsius, then this will come in equilibrium to form CH triple bond C, CH minus and CO2 minus. Hydrogen is lost from both the sides. This electrons will come here and this will come here. Finally, we get what is this one. See here, CH minus C double bond, CH, CO2 minus. Finally, the product which we get on addition of water is this one. CH2 double bond, C double bond, CH, CO2H. Okay. Now, this is the method to prepare alkene from alkynes. Another method is by using carbenes. What is carbenes? It will be discussed later, but you can just see how it is being generated. So, let us start. First, we are going to find out the reagent in proper way. When you add potassium butoxide into CHBr3, this is a base and this will abstract proton. Get C minus, H is gone, Br, 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 and take away the electron and the bond will get electron deficient. As a result, Br minus gets away and we are left with CBr2. This is our main focus of carbene. This will react with a alkene to form a cumulated alkene. So what happens is that first hydrogen is being abstracted, second is that bromine is going away with the electron pairs present here, and finally what we get is an electron deficient species of carbon with two substituent in it, and this is known as carbene. Now let us go for the preparation part. So in this case, if you see, take alkene RC, suppose Cr2, add the carbene into it, CBr2. Now how it gets added? It gets added by forming a cyclopropane ring. So we have Cr2 here, one bond is made by this carbon, one bond by this carbon. So we get a cyclopropane intermediate. Now how does the bond open up? If you see here, bond opens up like this. This goes away and this comes here. But for this to occur, we need to add magnesium to it. So this becomes Cr2, C, MgBr and Br. So this MgBr gets out, this bond comes here and this bromine goes out. And the final product which we get is there is an insertion of carbene within the double bond to form a cumulated double bond. This is third method of preparation of this kind of polyalkene. And if we focus into the another method, see here, this is the last method which we are going to see formally. We take Br, CH2, C triple bond, C, CH2, Br. Add zinc to it. Now once you add zinc to it, zinc gets inserted between the bonds of bromine and carbon in one side. So let us draw the structure which comes here: bromine, bromine, zinc, CH2, C triple bond, C, CH2, Br. Now what happens is that here there is transfer of electrons. So this bonds open up and gives the electron here. Here another electron comes from this bond, sits here, and the bromine carbon bond breaks up. So finally the product which we get is an extended conjugated type of alene, which is one carbon more than alene. So this is the final product. So this is how we can make cumulated double bond. And another method for making this one is to take formaldehyde, CH2 double bond O, CH2 double bond O, and you take alkyne. Okay, now to it add NaOMe. What happens is that these three moieties gets together. So we get C triple bond C, CH2 OH, CH2 OH, and when we add PBr3 to it, this OH gets replaced by Br, CH2 Br, C triple bond C, CH2 Br. If we add zinc to it, the final product is obtained, because zinc will insert in this part Zn, and from here this will move away just like the previous reaction, but our starting material is different. we are obtaining starting material from alkyne. Then we are coming here. So how to prepare this if it is asked, you need to follow this path. So same way we are getting our desired product CH2, double bond C, CH2. So this much was for the two types of double bond for polyalkenes. Now in the next class, we are going to deal with hydrocarbons with conjugated double bonds. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment.